So very good morning to all on the very last and the fifth day of this GAN course on climate change and compound hydrometeorological events, insights from data and modeling from 19 to 23rd May. ये लेना since you requested for the bias correction and all, so we will go with that, and then finally we will come for the drought competition. So if we talk about bias correction, I have discussed you that there are some bias correction techniques like distribution or quantile mapping or probability distribution mapping. So these are फिर we can say linear scaling of precipitation or temperature, or we can say variance scaling of temperature. So there are different techniques which can be done, which can be used for the bias correction. So for that, if you need the very simplest solution for bias correction, you can go ahead with the CM height. So I will let you know how we can do using the bias correction. We can do bias correction using the CM height. I think anyone you have any .nc file for any GCM, so that you can perform also, you can share in the group so that everyone can do that. Otherwise, for the CM height, you need not to have any other data sets with you right now. Whatever the data set is available in the CM height for the as an example data set, you can use with the, you can go with ahead that. So I'll share, like this is the CM height. Once you type on the Google that CM height, you will get this website. So initially you have to go for the very first link. So in this you will have three files to the download. The first one is CM height installer, the second one is CM height user manual, and the third one is CM height example data. So all three data set you can download. User manual you can go ahead so that you can have an idea that how you can perform. Otherwise, if you want to perform directly, you can download the data that is CM height example data. So there is historical data as well in this, and the files which we need to prepare as a text file for the CM height also, there is example for that. So initially we will go with the CM height installer. So you just need to download the very first file. You can do, I think, along with me, so that you have a better idea that how you can perform this. Means this is the simplest way you can do the bias correction without any coding, without anything. You just need to know what are your lat, longitude and the elevation of the point. That's it. Other than that, whatever the data, for example, if you want to do the bias correction for the precipitation, so for the raw period, or we can say the historical period, you have the IMD observed data, that is precipitation or temperature data, and you must have the future data. Future data you need not to have in the Excel file. Whatever the data set you are picking from the GCM, that is NC file, you take that NC file directly. No need to convert that NC file to any other format itself. So let's go with this installation. I think I have to share that link to the group so that everyone will get it. Yeah. So this is a CM height installer. download the example data which is required in this. So just download that. So it's done. So initially whenever you click on the CM hide desktop icon, initially this will come. So yes, once after this black screen, this will come to your screen. So this is the platform where you have to do that. I think in this you can see the processing and the plot part. So there are two works carried out by this CM hide. First one is the processing, in which it will do the bias correction, and the second one is the plotting, where whatever the data sets you have, either you have corrected the historical one using the observed IMD data set, or whatever the future bias corrected data set, you can plot here itself without using any Excel or anything other software for the plotting. The second important thing, since in the processing itself you have to select the variable here itself. So before going into this thing, we have to prepare the files. We have to prepare the download data which is required for that. So let's go for that. I think it's already okay, it is in process, but I think I have shared in the group also, so you can open that. In that you have one file, text file as PCP or TEMP. So you can name anything, but since all the names in the user manuals are like that, so I have kept that file name as like PCP or TEMP. So the PCP file which you have prepared, which you needs to prepare in the text format, is consist of 5 parameters that you have to do. I'll show in the user manual also. Okay, this is the user manual. You can go ahead with this, and initially you have to create the file which is required at the location climate data ASCII format, that is a location file, and in this file we have to use these 5 things, that is the ID. You can give any ID like 1, 2, 3, 4 for your identification, so that you have a number of that. Then the name, so name, for example, you have 10 grid points or 10 location like Bhopal, Indore, everything. So what you can do, you can write a name for Bhopal, then you can write the name for Indore, Satna, Jabalpur, anything like Delhi, then let of that particular place, longitude of that particular place, and the elevation. So you have to prepare this for one location. If you have several, you can make 10, you can give the detail for 10 points, 20 points, 1000 points, whatever the points you need to give, you can give here, and then you have to go for the next format. Next format is the data file, which is for the temperature or precipitation, because for example, if you have given the ID that is 1, name is like Bhopal, and you have given the let, long and elevation. So initially with the help of this Bhopal file, we have to prepare the Bhopal file also for the precipitation or temperature. So in this case you have to prepare this file. You have given this file name as a Bhopal and you have put here, but then you have to prepare this Bhopal file. So in Bhopal file, what you have to do, you have to start with the date. So I think data is already downloaded. We will show with the example so that you will get better idea about that. Okay, this is the example data, or this is the observed one, this is the precipitation. So this is the example. Initially we need to make this file. For example, we have 4 points where we have to do the bias correction, like the first one is Bhopal, second is Indore, third one is Chennai, fourth one is Delhi. So these are the ID names. Then the name of that file. For example, if you put Bhopal data in the first file, that is P53997. Second one is P539100 for Indore. So you have to give the name and then the let of that particular city or a particular study area, then longitude and then elevation. So this is the very first file you need to make. Then correspondingly you need all these files, that is P5, 9100 or 9103. So we have to prepare that. So these looks like that. So how it does, how we need to give the data set? We need to give, initially we have to give the year, then we have to give the month, and then we have to give the date. So it is like year, then the month, and then the date. These are the three things you have to give, because the software needs the exact date from which you are giving the data set. For example, you have the data set from 1st January 2000, so you will give the data set from 200101. If you have more than 20 years, 30 years, you can give anything. So initially you are giving, for example, if you have data set from 2020 itself, 2000 itself, so right now for this you are giving the data set for around 25 years, so 24 years till to 31st December of 2024. So you have to prepare the file for different areas or the grid points you have. So you okay, yeah, this text file is there. You just need to write the date, means mostly we have the data set in Excel file. So you just copy the Excel file data set, initially open the text file, write the initial date with the month and year, but the condition is that you should start with the year like 2000, then you start with the month, that is 01 like for January, and then you have to start with the date, for example it's 1st January. Then whatever the data set you have for 20 years or 24 years, you just copy it or paste it here in the text file and name it as anything you want. For example, you can write P1, P2, P3, and similarly you have to write that name here, 1, P1, lat, longitude, and please put these comma also, otherwise it will not, it will show error. Means you can do one thing, you can keep this example data file and you can just alter the file, modify the files according to your needs. Don't create the new ones. Once it's done, then you need the NC files for that. Then I think in the example, if it is there, we will use that. Yeah, NC file is there in this. Okay, so this is like precipitation or temperature data set we have, and for precipitation itself we have NC file here. So these are some of the NC files. They may be of the observed period, they may be of future period. Then we have to come directly with this, where we need to do this. So initially what we do, for example, if we want to do the correction for precipitation, you just need to click on the precipitation, then you have to select the location file. Okay, so for example, you selected the variable precipitation or temperature. I think why it is not for doing for precipitation, I have no idea right now, but I think yeah, it is also running for precipitation. So if it is not working, you just click on the second variable and then it will start working for the first variable too. So then you have to select the location file. Which file? Initially we have created the PCP file which have the data set for everything. Means you have to go for that PCP file. I'll show you. This is the desktop, and okay, download, then example data, and then observed, and this is the precipitation. So this PCP file you have to upload here. Then there are different methods which can be used for bias corrections. So usually there is some method like linear scaling. So linear scaling can also be done for precipitation and temperature both. Like variance scaling can be done, but variance scaling is useful only for temperature, not for precipitation. So how you get to know that which one is useful for precipitation and temperature both, which one is not useful for a particular data set? Is there any classification based on that we can use the bias correction method for particular variable? Any idea? The thing means, for example, we have a lot of bias correction techniques. So how we justify that this one can be used for both variables like precipitation, temperature, or any other variable, or this can't be used for this particular variable to correct the data set. So the thing is, it is based on the distribution. So you have idea about gamma distribution, Gaussian distribution and all. So if you correct these, some of the bias correction techniques are using only the gamma distribution. They are fitting the data into the gamma distribution only. So gamma distribution is only used for positive values, means like from 0 to positive value only. So if you put gamma distribution for the precipitation, is it valid for it? Yes, because precipitation can't be negative. For example, if some bias correction technique is fitting the data into the gamma distribution only, then that distribution or that technique can be used for temperature. Yes or no? Yes? How many say yes? For example, a bias correction technique is using Gaussian gamma distribution for the correction or fitting the data set. There is a technique, for example, X technique, to do the bias correction, in which all the data set is fitting into the gamma distribution, and then it is doing the bias correction. And gamma distribution have a property that it will have a value from 0 to positive values only. It means the positive only. So we are fitting the precipitation. For that we can do that. For that, bias correction technique can be used for a bias correction of precipitation data. What if we will use for the temperature also? Because temperature can also have negative value. So if you are going to bias correct that data set, it may correct the data set, but it will not correct exactly. It will do the wrong correction, because I think what it will do, it will treat all the negative value also as positive. Yes, if doesn't have negative value, then because this distribution have no relation with the temperature or precipitation value, it have relationship with positive or negative value. It doesn't care about whether it is temperature or like soil moisture data or anything. It needs only positive value to do that, because what initially gamma distribution is doing nothing. It is fitting the value, all the value into a distribution. That's it. After that, bias correction will take place. So if you are going for precipitation along with the temperature, means you want to fit only a same distribution, then you can't fit gamma. You have to go for Gaussian distribution. Gaussian distribution have negative, 0 and positive value. So like quantile mapping you say, or we can say distribution mapping. These are the same. Quantile mapping or distribution mapping are the same. They are only having different names, like quantile mapping, probability distribution mapping, or probability mapping, or we can say statistical downscaling. These are same. They are based on historical data sets. That's why in statistical, what we are saying, whatever the trend in the observed period, the same will be carry forward to the future. That's why we know that this is not possible practically, that whatever happens in the past, we are treating the same thing or carry forwarding that same thing to the future, but it is not practically possible. In this, we are considering one assumption, I think you know, that is stationarity. And stationarity doesn't exist. That's why we have another topic, that is non-stationarity, because stationarity is not existing, because whatever the climate we have in the last 30 years, we can't say that the same will happen in the next coming 70 years or 75 years. So here I will not go into deep, otherwise we will not able to do this. So distribution mapping we will do, because it use both distribution, that is Gaussian and gamma. So it will fit all the data set, precipitation plus temperature, or precipitation into Gaussian gamma and temperature into the Gaussian distribution. So we will do here. Then we have to select the net CDF file. So we will select the net CDF file from here itself. So this, for example, precipitation. Okay, so in this folder itself, I think we have net CDF file. I think in this example files it is not showing, that's why in the morning itself I asked about the LC file if you have. Yeah, okay. So in this, then you have to select for which scenario you are correcting the data set. For example, 4.5. In this it have only 4.5, and I think it is showing the file name also. Only one file, any one of the file, means in which you have to do the correction. I think you can see the time period is also showing, that is from 1996 to 2005. Since this is an example, means given by the CM Hyde. Here, if we are doing the bias correction, we will get the data from 1970 to 2005, or we can have the data set, I think, because this is for RCP. So for example, if this NC file have the data from 1970 to 2005 or 2015 itself, so we will give the same data set here itself. Okay, so here we will give the input file, and whatever the time period the historical NC file have, the same data set we will give in the that precipitation text file, that P1, P2, P3, P4, because there should be overlapping period time. So after that we have to select the folder in which bias corrected file will be saved. So we will select any folder in which we can save the output file, and for example let's do that here, like output file. So you write output, select this one, then importantly check all the files that there is no issue with the files, and once you click on the check files, then only these two buttons will get enabled, that is this and this. This is very important because it is establishing the relationship between the observed period which is given by the IMP and the observed period for the climate model itself. For example, your model is giving from 1970 to 2005, so you have to give your data set from 1970 to 2005 itself. Then this is the overlapping period. So please click on this so that it will establish a relationship. Here itself means right now it is showing Codex. This is an example only. You can download 10 GCMs. You have to go one by one. Initially, for example, you have Codex, then you may have C and RM GCM. Then you can go for the I think MPI ESM LR. There are different GCMs. Right now we have CMIP 6, so you can download 10 or 15 out of them. Then initially you have to go folder one by one. Initially you have to go for the first GCM, then you have to go for RC SSP first, second, third, fourth, like this. Okay, yes, because IMD data set for 1970 to 2015 is same for everyone. Means like as a 5 participants have modeled 5 given 5 GCM models. Okay, so you have taken something as a different thing. She has taken some different assumptions to create the models. He has taken something different assumptions to create the GCM models. So what we do at the end, that all three have declared this is the data set of precipitation from 1970 to 2015 by using different assumptions. But for all of you, the reference file is IMD only. So you will take 1970 to 2015 IMD data set. That is same for you. So that is here. Then you just start processing it. Once you process, the file which you get into the output format will be in bias corrected file. So this is the way to correct it, and I think we can see here. I think in the output we have PCP file, and this is the row and this is the distribution mapping, and you can see the file which is corrected here. For example, these are different files, so we will open one by one. These are output files. So whatever the input, if since you have given 5 input files, you will get 5 output files for that particular scenario of that particular GCM. So you can do this using some of the data sets. So I request you, if you have any GCM file with you, like NC file for any GCM, you can just proceed with any of your study area for like a grid point, one grid point between the break 11 to 11:30. So in that period, if you don't have any doubt for that, you can ask. Okay. So this is the bias correction, and in this, sometime you do one thing, that there are different ways to do the correction. So you can go with the minimum 2 bias correction technique, so that you can compare that which one is better. As far as I concerned, I have done the quantile, or we can say the distribution mapping, and results are very good in terms of precipitation or temperature data set across Sikkim itself. So because the reason behind the distribution mapping is only one, that it fits the precipitation into the gamma and temperature into the Gaussian distribution. So this is all about this. Then since we have to carry out the lecture also as per the GAN guidelines, so we will go further with this. And if you need the code for drought, so we can also perform that also. Means we can compute SPI, SRI, SSI and VCI in this class itself after just the break. So that I'll share the code for SPI, SRI, SSI and VCI. You just put the input variables, and I'll share the input files also for particular region itself for 1 or 2 grid points. Then whatever the study area you have, you just use Excel file instead of that and just run the code. You will get the SPI, SRI, SSI and VCI for all the study area. So in this, initially we will discuss what is the reason behind to carry out this study, and then what are the input data sets, and what are the code we have used in this study, and what are the input files we have. So in this we will discuss the occurrence, concurrence and evolution of meteorological drought across Indian river basins. So I think you know about the occurrence or distribution. That is very common word. What do you mean by concurrence? Any idea about concurrence? Repetition. 2 or more events occurring together. For example, here the concurrence means 2 or more than 2 types of drought, not the same drought type. Concurrence means, here in this study, concurrence means if meteorological drought is occurring with hydrological drought, that is the concurrence part. Most of the study we found that usually people find out the occurrence and distribution and the trend of any of the drought like meteorological or hydrological, but we can't say that only if meteorological drought is occurring, it is occurring continuously. No, sometime just after the meteorological, hydrological is occurring, means meteorological plus hydrological drought is occurring simultaneously at the same time. sometime hydrological plus agriculture drought is occurring at the same time. So that thing is known as concurrence. Second important thing, sometime a particular drought like meteorological is converting into another drought type, like meteorological is converting into agricultural drought. That is known as a drought evolution. So there are three important things whenever you are computing the drought. The first one is the occurrence or distribution of the drought. The second one is the concurrence, where more than two types of drought. It can be 2, it can be 3, it can be 4. When they are occurring simultaneously at the same time, and when one particular drought is converting into another drought type, that is known as drought evolution process. So in this study we have calculated meteorological, hydrological and agricultural drought. However, agriculture drought we have further subclassified into two types, that is known as soil moisture drought and vegetation drought. So let's discuss. So I already told that drought is further, agriculture drought is further classified into two types, that is soil moisture and vegetation, so that we can define the agriculture drought based on soil moisture and based on vegetation condition also. In this study we have not identified only the severe drought conditions or what is the spatial extent of individual droughts, but also we have done the concurrence of that, and finally we have also evaluated the evolutionary process among these four types of drought in this study. So this is simple description why we need to think about the drought, how these different drought types are occurring. So if we know about the climate change, so due to climate change we have climatic variability, or we have some alteration in our climatic variables. Due to that alteration, sometimes we have less precipitation, or it results into the no precipitation condition, or sometimes it leads to the high temperature, low humidity or high sunshine hours. So this lack of precipitation or precipitation deficiency itself leads to the meteorological drought. Similarly, due to this variability in the climatic variables, it will cause soil moisture deficiency, and this soil moisture deficiency will result in the agricultural drought. And finally, if we talk about the stream flow deficiency, it means whatever the average level of the water body is, if it is fall below the average level, then it is resulted into the hydrological drought. So this study has been carried out all across India in 25 river basins as per India Varis 2014 classification, like I have denoted by the numbers like 1, 2, 3, 4 and 24. So initially one is showing the Indus, then Ganga, Brahmaputra, Barak, Godavari, Krishna, Kaveri, Subarnekha, Brahmani and Batarni, Mahanadi, Penal, Mahi, Sabarmati and all. Then these are some of the data sets we have used, since this is an old study during my PhD itself. So the data set is up to 2013 only, but we can right now it is available till 2025 or 24, we can go ahead with that. So the thing is that for precipitation itself, initially in this study we have taken at 0.5 degree, but you can take at 0.25 degree itself, because we have precipitation at 0.25 degree from India Meteorological Department. This is my spelling mistake, please. So this is India, not Indian Meteorological Department. So this is IMD. Second, runoff and soil moisture is taken from NERA 2, that is modern era retrospective analysis for research and application. So if you are using soil moisture or runoff, you can go ahead with the MERA 2 data set. It is reliable, and we have published more than 3 papers using the MERA 2 data set for in terms of soil moisture or in terms of runoff. So if you want, you can go ahead with the MERA 2 data set, since it has different resolution. Along with that, for vegetation drought we have used NDVI, that is taken from GIMMS, that is Global Inventory Modeling and Mapping Studies. So that is also you can take, that is available at 1/12 degree into 1/12 degree. So all we have regraded into 0.5, but right now if you are doing at present time, please I suggest you should regrade into 0.25 degree, because this data set is available at 0.25 degree itself. At that time we have taken a 0.5 degree. Then the methodology of the study. So initially you have to take the data set like precipitation from IMD, runoff and soil moisture from MERA 2, then NDVI from GIMMS. Based on that you have to calculate the drought indices like SPI using the precipitation as input, runoff using runoff you have to calculate SRI, SSI using soil moisture, and VCI using NDVI as a input data sets. Once you've done this, then you have to characterize the drought. So based on SPI you can characterize the meteorological, based on SRI you can characterize the hydrological, then based on SSI you can go ahead with the soil moisture, and finally with the help of VCI you can go for the vegetation drought. Once you're done with this, then you can go for the other sub-objective of the study. So you can find out the spatial and temporal extent of the drought conditions, then you can find out the drought trend. So in this we have not used any drought trend method, like you have heard about the MK test, man-candle trend analysis test. We have not used any test to find out the trend, we just show the trend based on the decadal basis. So in this trend we have shown how the spatial extent of drought is changing on a decadal basis from 1980 to 1990, 1990 to 2000, 2000 to 2010, like that. Then we have shown the frequency, how frequency is changing across the decades, and then finally we have shown the third thing is that is the the severity, and finally we have calculated the drought concurrence means how two or more than two droughts occurring at the same time at the same study area. For example, if we talk about 1980, that how the drought are occurring in the Bhopal, two or more than two droughts are occurring in the same time in the same study area itself. And finally we have shown how the drought is evaluating from one place to another place itself. So like for example, meteorological is converting into hydrological, so this is the drought evolution process itself. So these are the classification based on the severity itself. We have used this because this classification is common for SPI, SRI and SSI. It is not worldwide famous. Some of the study says that if SPI value is just below 0, just like negative only, just below the 0 itself, it shows the drought condition. But here we have not used, we have considered this thing as a drought. Before that it is declared as abnormally dry, not the drought condition. This is declared by this paper in 2002, that if you have the SPI value below 0.8, minus 0.8, then only we can declare the drought, otherwise it's a dry condition. So these are the three common classification for SPI, SRI and VCI, SSI, and for VCI itself this is the condition. So based on that we can say we have moderate drought, severe drought, extreme drought or exceptional drought itself. So these are some of the results on the temporal extent, where we have seen what is the temporal extent of the drought across India. Then in this we found that April to July are usually judged as the most drought prone months, when all four kinds of drought usually occurs at the same time, means all the four droughts are occurring in these months specifically. So we can say these are more drought prone months, that is April to July itself. Then we have find out the result of drought trend, in which initially we show the mean duration, that how the duration is changing across the decadal basis. And we found that meteorological droughts remain slightly longer since 1982, that is increasing from some period from 2.16 to 2.32 months every year. However, other three are showing some decreasing pattern. Similarly, we go with the mean areal extent, means the spatial extent across all three decades, and we found that meteorological drought also having mean areal extent which is increasing from 1980 to 2013 itself. Then the same we have done for the frequency, and results are similar, that meteorological drought is showing the increasing trend across these three decades. So we can say that meteorological drought occur more frequently with more mean duration and higher areal extent. Then this is the drought concurrence, where we find out for, I have shown this figure only for particular river basin. We can show for other river basins also. So for example, in 1980 itself, 1984 itself, we can see in the May we have three drought types, that is meteorological plus hydrological plus soil moisture droughts. So in total, if we talk about this particular river basin, we found 31 concurrent drought events in last 20 years from 1980 to 2013, out of which April to July were identified as the multi-drought prone months with over more than 54% of this. You can see that majority of the concurrent events are occurring in these 4 months. That's why they are also known as drought prone months. Majorly, out of that you can see one thing, that most of the cases we have only two combinations. Most of the cases you can see. Some of the cases have 2, 3 or 4 combination. I think only where we can find out the one combination that is having all 4, otherwise majority having 2 combination. So we can say 2 drought based conjunctions are account for more than 70% or 71% of concurrent drought types, out of which 84 concurrent droughts included the soil moisture drought. Majority you can see that soil moisture drought is more consistent in all. So similarly I have shown here in the spatial extent form where we have shown the concurrence of the drought, and you can see that majority, that the April, May, June and July are having the most of the concurrent droughts, out of which the most important combination we are getting is hydrological plus vegetation, hydrological plus soil moisture and soil moisture plus vegetation. And based on this thing we can say one thing, that India is highly vulnerable to the agriculture drought. How? Because this is a type of agriculture drought. This is also a type of agricultural drought, and both are also a type of agricultural drought. So India is highly vulnerable to the agricultural drought in all the months itself. Then we have shown the results for the drought evolution process. So in this we have not done a lot of work for the evolution. We have very simple classification here. We have done whatever the SPI, SRI, SSI and VCI value we have find out the R square value. Means we just compare 2 drought indices at the same type like SPI and SRI, and then we have plotted its R square value. Then we have SPI versus SSI, then SPI versus VCI, SRI versus SSI and SSI versus VCI. All 4 drought indices we have compared the R square value, and you will find one important thing, that in which color is having the highest value. Out of 5 color, which color is having the highest value every single time for all the river basins? SRI versus SSI. This one black color, that is runoff versus soil moisture. So this suggests that this runoff is also related with soil moisture. So 50% of soil moisture deficit can be explained by the runoff deficit. If we have runoff deficit, we also have soil moisture deficit. So this is the relation. So based on that we can say, if we have this type of drought, we must have this plus this type of drought. It should indicate that only. If we have SRI drought, means the runoff drought, or we can say hydrological drought, we must have hydrological plus soil moisture drought because of this relation. But when we found the result, we found that occurrence of hydrological drought is about 73% more than the hydrological plus soil moisture. It means hydrological drought is occurring, but due to that deficit we don't have soil moisture drought. Why it is so? Because we have the issue with the hydrological drought, but we are not allow agriculture drought to occur because of the irrigation. Because we have the deficit of soil moisture due to runoff also, but since we are compensating with the irrigation process, that's why this value is not equal to this. However, it is more than 73%, and the reason is that we are doing the irrigation at very high rate. If we talk about very old data itself, at that time Indo-Gangetic Plain is having more than 40% of irrigation rate during 2009 to 10 as per the government data platform India. So if we are not doing the irrigation, this should be equal to this, but it is not equal to this because of irrigation practice we carry out across India itself. Then we will go for the second important thing, that is result for the drought evolution. So in the drought evolution itself, you can calculate also the another thing to find out the drought evolution, and that is known as the time lag. Time lag means if one particular drought is occur, then the second drought will occur in which month. After, if we find out the value and it is coming out 1, then it will indicate that 1 month is required to evaluation of drought from one type to another. So we have calculated this. If this time lag is very less, it means evolution is very fast, and if time lag is more, it means drought evolution process takes long time. So in this we found we have no time lag between these 3-4 kinds of drought. It means we can say this drought evolution can take place in India typically within a month, within 1 month itself. So if it is transforming within the 1 month itself, then what the solution we can have? We must go for weekly studies or bi-weekly studies, because this studies has been carried out on monthly basis. So you can go ahead with the weekly or bi-weekly studies, so that you can find out the time lag between one drought to another. Maybe it's 7 days, maybe 10 days, or maybe 15 days or more. So this is all about this. Then we will go for the conclusion part. So in this we found that hydrological and soil moisture drought are usually more severe than the meteorological and vegetation drought in most of the basins. 2 drought based conjunctions, because we talk about the concurrence, so 2 drought based conjunctions are more than 70% of concurrent droughts. It means mostly we are having concurrence of 2 or more than 2. Then third, April, May, June, July are identified as multi drought prone months across India. Combination like hydrological plus vegetation, hydrological plus soil moisture, or soil moisture plus vegetation are the most observed drought combination as compared to others. And the evolution process of drought of different types are typically takes place within a 1 month itself. So we must go for weekly studies or bi-weekly studies, so that we can have better idea for the drought transformation, that how it is happening across different days. So this is all about univariate analysis of drought. But can you suggest that if we are going for univariate analysis of drought, is it give the better picture about the drought condition or drought characteristics? Because drought is a very complex phenomenon. So if you are finding out like drought duration, or if you are finding out the drought severity, carrying out the study for a univariate analysis, like separately you are finding out the drought duration, then separate you are finding out the severity, will not help you to find out the exact picture of drought duration characteristics, because they are interrelated with each other. You are suggesting something based on the drought duration, you are suggesting something based on drought severity, but can you say that these two things are separate from each other? Drought duration and drought severity are interrelated, or they are separate? They are interrelated. But in this study what we have done, we have calculated the separate analysis, we have calculated using the univariate analysis. So we have to go for the multivariate, or we can say for initially we can go for bivariate, then further we can go for multivariate like trivariate or like. Yes, for example, if you are calculating the drought duration and severity, you can find out the joint combination or joint distribution or joint probability of duration plus severity. If this is the duration and this is the severity, what will be the case? If duration is less, severity is high, what will be the case? If severity is less, duration will be more, what will be the case? If both are very high, then what will be the case? So this distribution or this probability distribution we must know. So initially we can go for univariate, then we have to go for multivariate. In the multivariate we have lot of options to go for the multivariate distribution, but there are lot of disadvantages in the multivariate distribution. There are different techniques, yes. How we can define the severity? Yes, in the next slide itself I will show that what is duration, how we can compute the duration, how we can calculate the severity. So with the help of figure I will show. So there are lot of multivariate distribution, multivariate way in which you can do this instead of univariate. But the thing with the problem is there with the multivariate is that most of the multivariate distribution have one assumption, that if you are having two variables and you are fitting them, both of the variable must have same distribution. This is the problem with the multivariate techniques. That for example, you have duration, you have severity, and you are fitting into multivariate distribution, then the condition is that duration and severity both must have either normal distribution or both have log normal distribution, Weibull distribution, gamma distribution, Gaussian distribution, but they must have same. And it is practically impossible that duration may have normal distribution or severity may have log normal, vpol, gamma, any other distribution. So to remove this limitation of multivariate distribution, copula come into the existence. Copula help in this. Copula doesn't have the assumptions that this and this must have same distribution. No. If you have a 3 variable, all 3 can have different distribution. If you have 4, all 4 may have different distribution. So this is the role of copula. Then we need to carry out the study using the bivariate analysis or trivariate analysis or multivariate analysis using the copula based approach. So let's go for the second lecture of today from 10 to 11, that is copula based analysis of all these dots which we have discussed initially for the univariate analysis across Indian river basins. So let's go, and initially I'll clear your doubt. So this is drought duration and drought severity. So in this study, since we have taken the different classification, because most of the studies suggest that if the drought indices value is just below the 0 also, you should consider that value as a drought condition, because we have gone for a lot of review of our last paper. So most of the studies, most of the reviewers suggest you should take negative value just below the 0, you have to consider it as drought condition. So in this we have taken below 0 value as a drought condition. So what is drought duration? You can see this value is above 0, so this is not a drought condition. Then these are monthly basis value, not a daily basis value. These are monthly basis. So for the very first month, this is first month, this is second, third, fourth, fifth, seventh, 10th month, then 20th, then 30th month. This is the data set for 30 months. So initially for very first month we have positive value, so that is not a drought condition. The second value, it comes like -1, so obviously it is a drought. Then SPI value comes in minus, that is also a drought, and then positive. It means here we don't have drought. So we have drought here only for 2 months. So duration will be 2 months. Then what is the severity in this case? Severity is the addition of these two negative values. Summation of all the negative value, either it is SPI, SRI or SSI, whatever the value you have, it can be SPI, it can be SRI, it can be SSI, whatever the value you have, just make the cumulative summation of negative values. Why so negative? Why we are not taking positive value? Because for the negative, positive value we don't have drought conditions. So for positive value we don't count, we count only for the negative values. For this case only 1 month, for this case we have 3 months, and the severity is this plus this plus this, this plus this is the severity for the 4th event, this is the severity for the 5th month, this is the severity of 6th event, and this is the severity of 7th event, having the duration of 2 months. So this is a calculation of drought duration and severity. You just do with this. So whenever you are writing a code, please don't go blindly that you got a code from anything like ChatGPT and you just run it. Whenever you are doing the calculation, you do this thing on Excel file or on our paper itself, that you are getting 2 months, what about the code? If you are getting only 1 month, what about your code itself? Sometimes if you don't have particular idea about your code, you just run it, it will show 5 months, you can say okay, maybe 5 months duration or drought is there. You have no idea about that. Just go for practical things. You just need to also check with the Excel file or just write on the paper only. If you are getting this thing, then okay, you can proceed with the code also. 1 minute. return period of the drought, you will ask me this, what is L? So L I will discuss here. This is the starting of this event and this is the starting of second event. So starting of first event to the starting of second event, the duration between the initial starting of the first event to the starting of second event, the duration is inter-arrival drought duration time. So that will be useful as an input variable to the return period. So you just check what is inter-arrival. Okay, here this is this event is starting and this is the starting of second event. So this is the inter-arrival drought time. That L is useful as an input in the return period calculation. So let's go for highlight of this study. So in this study we have calculated the joint dependence structures among drought characteristics of all drought types, like we have calculated the joint dependence among drought duration and severity for meteorological, hydrological and agricultural droughts for across all the India using multivariate technique. So copula based approach is selected in this to calculate the joint dependence. Joint dependence means we are using two variables and we are finding out the relationship between these two variables of different droughts. In this we have calculated the accidents probability, because once we got the joint dependence probability or joint distribution between drought duration and drought severity, we can find out the accidents probability, we can find out the conditional probability, we can find out the joint return period, and we can find out the conditional joint return period. You have any idea about the conditional or accidents probability or joint return period or conditional return period? What are the types of return periods? There are I think two types of return periods. Any one of you have any idea return periods type? No? Okay, so return periods are also of two types, that is and or. And we have accidents probability, conditional probability. So we have calculated all these things at different percentile value. This is the lowermost, this is the highermost, and we have also taken the intermediate values, and then these 4 percentiles we are calculating. The same will be used for condition. We will put the condition that first variable is reaching this value, second is reaching this, first variable is reaching this, and second variable is only for this. Why it is so, I have discussed before also. Sometimes duration is very high, severity is less. Sometimes severity is very high, duration is less. So there are different combinations. So we have to look this, whether combination can be high severity, high duration. It can be less duration, high severity, or vice versa, like that. So we have to combine all the conditions. So that is known as conditional probability. Accidents means you can say, so duration should exceed this value. Also along with that, for example, duration also exceeds 95th percentile, severity also exceeds 95th percentile, means both variables are exceeding the same percentile at the same time. That is known accidents. If you are putting any condition like, no, my duration is exceeding this but severity is very less, or vice versa, then conditional probability come into the existence. So let's the study area is same for the study also. We have selected 24 river basins across India as per India Virus 2014 classification. These are the same data sets we have developed, and the methodology is that initially we collect the data set, computed the drought. Based on that we have computed the drought duration and the severity, that are two characteristics. Further, we have employed a test that is known as man-candle test to find out the significance, trend significance, and if trend significance results we are not able to get the proper trend. Why it is so? Because we are using univariate analysis initially, and in univariate analysis obviously we will not get the proper trend. So since we don't have significant trend in the univariate analysis in this, then we have to go further for the copula analysis, that is D, S. Initially you are treating D as separate, S as separate. Right now we combine into a same thing. These are two different parameters, but since they are interrelated, initially we keep these two parameters into separate rooms, but these two variables in the separate separate rooms will not give the proper interpretation of drought characteristics. So we have to keep both of them or three of drought variables into the same thing or into the same room, so that we have a proper idea about the drought characteristics. So in this we have taken drought duration and severity. In the future study you can take the third variable also. So if you are taking 2, that is bivariate. If you are taking 3, that will be a trivariate analysis. So based on these two we can calculate the joint distribution, and with the help of joint distribution you can calculate the accidents, you can calculate the conditional, you can calculate the joint return period, or you can calculate the conditional joint return period. Whatever the return period you are getting, if you are putting condition like this, then it will be result into the conditional return period. So this is the flow chart of the methodology. So initially we have computed the drought characteristics like drought duration and drought severity, and we have mean drought duration and mean drought severity. But initially you can see using the MK test we are not getting the proper analysis, or we are not getting the proper information about the drought. We are getting only limited assessment. So we have to go for the multivariate approach, and we have to develop the joint dependence between these characteristics. So we will go for the man candle test. So you have idea about MK test. What is MK test? Trend of the data set. So what will be the output of this? Either it will be positive, negative, or no trend, or insignificant trend, or positively significant, positively, or negatively significant. Okay. What about the value? Means this is only a trend, but if we want to find out its value itself, how much it is going to be increased, how much it is going to be decreased, then we have to go for sense slope only. It will show only the trend, either it is positive, negative, or no, or insignificant. If you are concerned with the value also, with the quantity value, then you have to go for the sense slope itself. So right now this is the very oldest method for the trend analysis. Recently we have lot of other methods, so you can go for that because it is highly saturated. So it's better you can go or you can adopt the different new methods for the trend analysis. So what is the 5% significance level? I think whenever you see the MK test in the paper, it is always mentioned 5% significance level or 0.05. Why? What is this? %? In what? 5% error in the data set. Any other? How many of you have seen a paper with the MK test? So can you recognize what is 5% significance level? Okay. So whenever we are going for the man candle trend analysis test, we have one hypothesis that is known as null hypothesis. So we say that is H naught, that is that we say that no, there is no trend. That is null hypothesis. And second one is true, yeah, we can say accepted. So that is H1 we can say. So in null hypothesis we say there is no trend, and other than that we say yes, there will be a trend. 5% significance means there are 5% chances that null hypothesis is accepted. It means there is no trend. 5% chance that there is no trend. 95% is there is a chance that null hypothesis is rejected and the second one will be accepted, and 95% chances that there will be a trend in the test, or in 95% chances that there will be a trend in that particular data set, and 5% is saying means 5% chance that that null hypothesis which is declaring that there is no trend. Usually it is shown or indicated by H naught, and second one is which is declaring that trend is there, that is shown by H1 value. So this is this. So So usually 5% value are taken. In very rare cases we have 1% significance also in some cases. Mostly we used to take 5%. In this MK test we usually find the Z value. Z value can have different range. If it is equal to greater than 1.96, it will show that there is a significant trend. If it is below this, this will be a significantly negative trend. And if it is between anything value between greater than 1.96 to minus 1.96, it has some trend, but that is not significant. For example, if it is 0 to this value, it is insignificant decreasing. If it is from 0 to this value, it is insignificant increasing. Or if it is having 0 value, then 0 means no trend. There is no trend. Below this, from 0 to this, it have increasing trend but not a significant one. 0 to minus 1.96, it have, but it have insignificant decreasing trend. Below this, more than this will have significant increasing, significant decreasing, and Z is 0, it means no trend. Okay, how many you know how to perform this test? If I will give you a, for example, we need to give a quiz in this, or we can give an examination, or anything we need to conduct after the 5th day. So this is a condition from the Gyan that we have to carry out an exam or quiz. So if I will give you this task that just after taking the lunch you do the MK test, how many of you can do that? This is the most simplest trend analysis test across last 50 years. And I think everyone who have studied paper related to drought, flood, or any other climatic extreme events, you encountered about the MK test. So what you will do? You will do using them Excel, or you will do with any other coding language? Python? Okay, I will share a code with you of the MATLAB. So you I'll share the data set also. So you just perform the MK test after the lunch. Not to show me, just for your research work. You can take that code, you can take the data set, you can perform that. So whenever you are going for your study, you can find out the MK test for your study itself. I'll share the code for, I think, MATLAB or R, whatever I have in my laptop, I will share it. Otherwise, it's 1-2 line code, we will make it, no issues. So that you can, but I'll share with the sense loop also, because only to show whether it is a positive or negative trend, it doesn't help you much. But if you have the value also, what is the increasing trend or what is the decreasing trend value, then that will help you more. So I will share the sense loop and MK test code combinedly. If it is not showing the trend, it means we can include more variables to find out. For example, right now we are getting So if you are not getting trend, what do you do? So initially, the thing is that if you are calculating something like univariately, for example, that particular event is governed by 2 variables or 3 variables or 4 variables, like heat waves, you are taking temperature only. If you will include another 2 parameters, it will have better, it will give better clear picture about that. So in that case, whatever the result you use after getting using 3 variables as an input, it will have proper significance. So it will give more significance of trend rather than using univariate. That's why initially we have calculated duration, initially we have calculated severity as separate. In both of them we are getting insignificant result. You can see that we have calculated the duration for meteorological, hydrological and soil moisture. We have calculated the severity for all 3 drought types, and in most of the cases you can see this is insignificant increasing color is there, insignificant decreasing color and increasing color is there. Only some part have significant increasing and decreasing trend, because so you can say that there is a trend, but not completely significant value. It have trend, but it is insignificant. You can't change the data set.
What can I do? The other techniques, other just like new technique of trend detection like IDA, other methods that I want to study. But the Manhattan, we have the two approach. Modified Manhattan are also there. They have the no need to rewriting and then apply directly on the series. Then after I will study on the external looping. We have studied on the 28 district temperature and precipitation data. We are finding out the trend. We are getting only the 4 and 5 district that are significant. But the challenge is if you are getting the insignificant trend, what can we do? We can do the change in the p-value, confidence interval change. Either what can I do to get the significant trend?
You can change the value till 10%. Yes, that you can change. But if there is no trend, why you want to show the trend? If it is not having the trend, you can't show the trend. Second important thing, you can go for sense law, where you can show this is the insignificant trend because this increase is very less. You have to show why it is insignificant. You can show by the sense law value that if we in some of the area we are finding out the significant increasing, so the increasing trend value of sense slope is this much. But however, in these areas we have value less than this, so we can't able to get the high or significant increasing or decreasing trend. That is the first thing. Second thing, if you go for the advanced version of trend analysis test, which are lastly for first 5 years people are using, you can go ahead with that also, so you will get better idea about that. Otherwise, if you don't able to get the trend, there is nothing wrong with that. You can show with the sense slope, this is the reason, this is the slope, that's why we are not getting to that. Otherwise, you have to go for the bivariate or trivariate things, because initially we have calculated duration severity, we are not able to get for whole of the India, so there is nothing we can do. Either we can change the value, no, just go for the bivariate, just go for the trivariate itself. So this I already written that these results are showing no significant increase or decrease in majority of the study area of India across all 3 drought types. So it is very challenging to understand these joint dependence of drought properties due to their random variability. So it's better, we need to go for some better plan, so we will go for the copula. Anyone you know about the drought copula? Two random variables means any random variables you can take either 2 or more than that. It will help you to find out the joint distribution between these 2 variables. For example, we have duration, we have severity, we will apply the KS test. The KS test will do nothing but it will find out the using the KS statistics, it will find out the best marginal distribution. What is marginal distribution? Distribution, what are the types of distribution you know? If a data set is there, for example, you have precipitation, you have temperature, so that data set can be fit into distribution. So can you tell any name of any of the distribution? Normal, log normal, Vibhul, gamma. So these are a lot of distributions we have. So initially copula will do one thing, that it will take duration as separate, severity as separate, it will fit into the distribution. So how it will fit into the distribution using KS test? KS test will do nothing, KS test will only one important thing. Initially, for example, it will fit, for example, this is the ECDF. means it is the empirical distribution fit into that. This is nothing but it is a empirical distribution in which data is fitted. Then we will go for the one by one distribution. For example, then we will go for example for another distribution is distribution number 1. Then we will go for the distribution number 2. Then we will go for the distribution 3, like this. Then what we will find from the ECDF, we need to find out the maximum difference between this to this. That is the maximum difference like C1. Then we will find the maximum difference like C2. Then we will find out the difference between this, that is maximum 3. Out of these 3 maximum, the minimum will be need to be find out. I think this is the minimum. So this will be the best distribution for that particular variable, like precipitation or temperature. So based on this case test, this case statistics, we will find out the best marginal distribution. So right now we have distribution for duration and severity. I think I have declared initially when I talk about the copula that copula doesn't have a condition that both the variables must have the same distribution. So here we have different distribution for duration, we have different distribution for severity itself. Once we got the distribution separate for both of them, then we will apply for the copula parameters for different copula like Plackett, Gumbel and Frank copula, and based on that we will find out the best copula function using the AIC and BIC using my maximum likelihood approach, and using best copula function we will go for the joint distribution. Joint distribution itself, you can see that initially we are talking about duration, it's different, and then severity different. Right now we have duration and severity in the combination, and we are finding out the joint distribution of copula together. And once we have joint distribution, we can go for conditional, we can go for accidents, we can go for return period, we can go for anything, but initially we need to have a joint distribution. From the initially starting itself, we have taken duration separate, severity separate, but once we find out the best copula, we can take them together using the copula things to find out the joint distribution. So let's discuss what is copula, copula methodology. So I have discussed about the accidents in a very layman terms. For example, if you want to find out the accidents probability where you have drought duration and you have drought severity, so if both of the variables are exceeding a specific certain threshold simultaneously, for example duration and severity are exceeding 95th percentile at the same time, then that is known as accidents probability. Then we will come for the accident conditional probability, where we are putting some condition that this will remain same, this will change, or this will remain same, this will be changed. It means conditional probability means we have condition like we are keeping duration as 95th percentile and we are changing severity from 25th to 50th to 75th to 95th percentile and vice versa. So this is a conditional probability for duration and severity cell. You can see here we are changing one thing, here we are changing one thing. In both of them we are keeping one thing same, one thing we are continuously changing. Then we talk about the return period. So return period itself, I talked about that L. I initially in the figure itself, that is inter-arrival drought time. So if we talk about the univariate return period, it is inter-arrival minus divided by 1 minus marginal distribution of drought duration or marginal distribution of drought severity. It is not taking both of them, not duration, either it will take duration, either it will take severity or any other variable. But once we come into the joint return period, it will take duration as well as severity plus their joint also. So this is end return period. What is the difference between end and or? Here we are taking both duration and severity at the same time like FDD and FSS, but here we have removed that, we are taking either of them. So this is the end and or return period. So this is conditional, so it's the same thing. In the conditional we have the same formula for joint return period, but we are applying any one of the condition. Either duration will increase and severity will be same, or severity will be same and we are changing the duration itself. So these are some of the results where we discuss about the bivariate analysis or bivariate analysis of accidents probability. So in this we found that meteorological drought, most of the basins in the country were susceptible to meteorological drought conditions based on this, and this is the conditional period. So if we talk about the conditional return period across India, river basin like Tapi, Godavari, western region like Luni and Sabarmati basins are of India and show higher conditional probability at 50th percentile, and in case of hydrological drought or soil moisture droughts, mostly the southern river basins are showing the more susceptibility at 50th percentile conditions. Then we found end joint return period. So if we talk about the meteorological drought condition, almost every single part of India is showing very small return period. It means, what is the small return period indicates? If small return period is there, the what does it indicates? Frequency will be more, because after a short period of time it will start again. So this is a significance, and some of this study suggests that drought events at these threshold are very common in southern region and have a shorter return period. In the southern India, we have very shorter return period. It means they are occurring very frequently in the southern India itself. So this southern shorter return period in the southern India is also validated by a study carried out in 2018, which is only specifically carried out for southern India, where they conclude that frequent drought events occurrence once in every 5-6 years in a larger part of southern India. In some parts we are getting high return period, but in southern India we are getting around 5 to 6 years only. Then these are results for the conditional return periods, where we have the similar types of results, that drought events are more common in southern India and they have shorter return period as compared to other parts. So initially we have calculated the return period for the normal conditions, like both are exceeding the certain period, but once we also calculate the conditional return period also, where we are putting the condition, then that also shows that we have very common drought conditions in southern India and they have very shorter return period as compared to other parts of the India. So based on that we can conclude that from the probabilistic analysis it was observed that copula can be used as an effective tool for joint dependence of drought characteristics and their joint return period for better investigation of drought parameters. It means if we are going for univariate analysis of drought characteristics, it will give a limited assessment description of the drought characteristics, but if we employ the bivariate or trivariate or multivariate characteristics analysis of drought, then we will get better clearance, clear picture or better idea about the drought characteristics as compared to univariate analysis. The second thing is bivariate analysis is incorporated to assess the joint dependence. Why we have used bivariate? Because we have two variables with us. If we have three, we can go for the trivariate also. And then southern India. So southern India have higher accidents probability and smaller joint return period. However, similar results are also observed for conditional return periods. So based on this thing that it have higher accidents but lesser smaller joint return periods, what does it indicate? That drought events in western or central India, they are more severe and they having longer return period. So they are occurring on longer period of time. Whereas if you talk about the southern India, they are more frequent because of smaller joint return, but they are less severe also. So this is all about the conclusion of this. So thank you so much. In the next lecture we will discuss about the flash drought. So I'll share how many of the participants need code related to droughts, like SPI, SRI, SSI, VCN. All ISER people will need it. PPT I will share. So I'll share MK and SenseLog test also, means the data set and the code, so that you can run, means during the lunch itself I'll share. And what about the valedictory? At what point of time you need it? Means around 1 or 12:30, 12:45 we have lunch. So 1:30 I think we can start, or we can start at 2. thing is that we have to take your feedback as well as your quiz, that is mandatory part, so that also will take around 30 minutes. So if you will start very fast, minimum means at 1 we can give you the feedback form and that quiz itself, but you have to fill till 1:30, because before that we can't start the valedictory. Okay, so if someone is sitting in the hostel or anywhere else, please ask them to come for the valedictory and for the quiz itself. Okay, for example, someone is working on flood or a different topic other than drought, so he or she may not come today, but please ask them to come around this time. Okay. Okay, you can have your tea. in last two lectures we have discussed about the traditional or conventional drought like meteorological, hydrological or agriculture drought like vegetation drought or soil moisture drought. In that we have discussed about the drought characteristics like the mean aerial extent, frequency of the droughts, other characteristics like mean aerial extent, mean duration, frequency, univariate analysis, then bivariate analysis, calculated the accidents probability, conditional probability, joint return period in which we have calculated end return period or return period, and then finally we calculated the conditional return period. So that two lectures are related to normal or we say conditional or traditional or conventional drought types like meteorological, hydrological or agriculture drought. In this we will discuss about the new type of drought which has come into existence in last 5 to 10 years, that is the flash drought. So if we talk about current climatic condition of hydroclimatic extremes over India, I think I already discussed with you that we are vulnerable to drought conditions, we are vulnerable to flood conditions, we are vulnerable to heat wave conditions. Also we are observing that based on the study which is carried out by Roxy et al. In 2017, that in last 65 years from 1950 to 2015 there is a 3-time increase or 3-fold increase in the extreme precipitation events across India. So in joint to all we can say that we are vulnerable to maximum of extreme events either in terms of flood, drought, heat waves or extreme precipitation across India. So before starting this we need to know why these types of events are occurring. So we know that due to greenhouse gas emissions there is an increase in CO2 concentrations, and due to this emission of CO2 we have change in the climatic conditions. And if we talk about the human influence also, due to human influence there is a change in land atmospheric interactions. So the combined effect of change in climatic conditions and the change in land atmospheric interactions, all these causes will result in various impacts such as change in the magnitude of precipitation, increase in the temperature, decrease in the relative humidity, soil water deficit, or we have groundwater reservoirs, so there is a depletion of groundwater reservoirs due to these type of climatic change condition or change in land atmospheric interactions. All these impacts will result in various possible extreme events we know like floods, drought, extreme precipitation, heat waves, cold waves and different other extreme events we have. Out of which this study which will more focus on drought risk, because there are several risks associated with drought, like we have reduced arable land productivity during the drought condition. During the drought conditions we observe that there is a rapid decline in soil moisture, and this rapid decline in soil moisture is the reason to cause the flash drought. So this is one of the important aspect or one of the important risks which we observe during the drought conditions. So this rapid decline, usually in the normal drought we have decline in soil moisture, but it is not on a rapid manner. It is declining very gradually, very slowly over a long period of time. It may take some months, sometimes some seasons or sometimes year to attain their maximum intensity. But in case of flash drought, there is a rapid decline in soil moisture within a very short period of time, and that will cause a new type of drought, that is a flash drought. Other risk associated with drought is insecure freshwater availability. We need to think about the freshwater availability because in droughts we have risk of this, and due to this we have increased water related diseases. So let's focus on flash drought. So from last 5 to 7 years we have lot of news regarding the flash drought. Some of the study across globally, they claim that this flash drought is a new type of extreme weather event. Some of the studies says that it is a new type of climate change effect, because initially I think the study has been carried out across China or USA or Europe. Then further all this study related to flash drought has been carried out across India also. So based on these studies they claim that this is a new type of extreme weather event. Some of them says that it is a new type of climate change effect. But the important thing from papers we got to know that some of the studies says that even the damp condition, which are usually not very vulnerable to the normal or conventional drought conditions, like if we talk about India, the northeast India or like Western Ghats, they are usually not vulnerable to drought conditions. Mostly the Western India like Rajasthan are mostly vulnerable to drought condition. But some of the study carried out across like New England, this found that even the damp condition or humid conditions are also hit by the flash drought. The same thing they have done for the future, and the future projection of flash drought also suggests that these flash drought events are also increasing in the future period over the humid regions or semi-humid regions. These are the two photographs for the USA itself, and these two photographs are in period of 41 months. The first photograph is taken on 1st July and second one is taken on 11th August. So after 41 days, we have the effect of flash drought from the greenery to this condition itself. So this is the effect of flash drought within 41 days. The same effect if we observe in the normal drought, traditional drought, or we say conventional drought like meteorological or hydrological or agriculture drought, maybe this effect can happen within a month, season, or sometime year, but the same effect can be visible, can be observed in the flash drought within a very short period of time. So based on this we can say yes, we need to carry out more studies and we have to go for faster forecasting of these flash drought events according to this research itself. So let's introduce the flash drought. So if we talk about India, India is one among the most vulnerable drought prone countries in the world, with at least one drought occurred in every 3 years in the last 5 decades. But this statement is majorly focused on traditional drought, not the flash drought. This is for the conventional drought like meteorological and agriculture. But recently, recent studies have focused a new type of, or recent research revealed a new type of drought which is known as flash drought, and it is claimed as a new type of extreme weather event. So how these two are different from each other? If we talk about the traditional or conventional drought, they are very slow growing climate phenomena, because whenever we see the definition of drought, it is always written that they are very slow growing climate phenomena and they takes months, sometimes seasons, or sometime year or more than that to attain their special extent or to attain their maximum intensity. But in contrast to these traditional drought, flash drought are different from conventional drought because they are not slow growing climate phenomena, they are very fast growing climate phenomena, and they have two important parameters, that they have quick onset and rapid intensification characteristics. So quick onset and rapid intensification means the onset means the start of the event. That start of the event is very fast, very quick, and at every single time step the intensification is very rapid. For everything, for example, if we take a time step of 5 days or 8 days, every 5 to 8 days we have rapid intensification of this type of event. That's why it is characterized by quick onset and rapid intensification. And due to this rapid intensification, it causes quick reduction of soil moisture, and this reduction in soil moisture at a very high rate or very fast rate will leads to the vegetation stress. So in this study we have developed a novel approach to define the flash drought using the new type of indicator that is known as aridity index. So we have developed a definition based on aridity index. We have very common formula available in the literature for so long, that is for the aridity index, but that aridity index value we have converted into the aridity index percentile, and based on that we have developed a method. So in this we have developed a method to define the to define the flash drought based on this aridity index. And for the very first time, the flash drought impact on terrestrial ecosystem, our Indian river basin, was investigated in this analysis. Give me a minute please. So in this study, initially we have defined the flash dot using the aridity index, percentile, and then further we have find out the impact of flash dot on the terrestrial ecosystem across Indian river basins. So these are some of the data sets used in this study. So initially we have used a precipitation data set in this study, that is derived from India Meteorological Department, which is available at 0.25 degree into 0.25 degree. Further we have used temperature data set. Since the resolution of temperature is coarse, that is 1 degree by 1 degree, but since it is available from the India Meteorological Department, we have taken it. And finally we have regraded into 0.25 degree by 0.25 degree using IDW, inverse distance weighing method. Third thing we have derived from Delhi potential evaporation, which is taken from GLEAM dataset, that is Global Land Evaporation Amsterdam model. So if you are looking for EP dataset or if you are looking for soil moisture dataset also, you can go for the GLEAM dataset. GLEAM dataset have high reliability whenever you are taking the soil moisture dataset or evaporation dataset also. In case of wind speed, we can take from the Princeton University. In terms of relative humidity, we can go for the NCP or NCAR reanalysis dataset, that is National Center for Environmental Prediction or National Center for Atmospheric Research. That dataset is available at 0.5 degree, so we have to regrade it to 0.25 degree to 0.25 degree. Then we have soil moisture dataset in this study. So we have one issue with the soil moisture dataset, that if we talk about soil moisture, we don't have in situ or observed soil moisture dataset across India. So what we have to do, we have to find out the soil moisture dataset from any satellite or reanalysis datasets. So what we have done, we have taken the soil moisture dataset from different sources. Like initially the first one is ESA CCI SM combined dataset, that is European Space Agency Climate Change Initiative soil moisture combined dataset. What is combined? Because this dataset, the soil moisture dataset from this source have three types of dataset. The first one is calculated using the active sensor. The second one is calculated or observed or collected using the passive sensor, and the third one is the combined using the active plus passive sensors. Means whatever the advantages or disadvantages of active and passive, they have combined it to make it more better. So that is the combined dataset. So we have collected that one, not active, not passive. So that is European Space Agency Climate Change Initiative soil moisture combined dataset. Further, we have also used the Global Land Data Assimilation System version 2, that is GLDS NOAA soil moisture dataset. Third, we have collected the ERA dataset. Fourth, the MERA2. I think in the last two lectures itself we have used this dataset, that is MERA2. And the final one is IMDAA soil moisture dataset. Anyone you have visited IMDA website for any type of dataset? Okay, so this is India.
Another one is satellite from USA, active passive.
Which one?
Active passive.
Active passive? Yeah, you can take any soil moisture dataset, there is no issue. Means these are based on the literature. These are the most widely used soil moisture dataset across India, across globally. So we can take any one. However, we have to use only one. So we will find out the best soil moisture dataset for our study area. So initially we don't have in situ or observed soil moisture dataset. So we will collect from different sources. You can collect from 7. I have collected from 5. You can collect from 10 sources. Then you have to apply some technical approach through which you can find out the best one. Because in the absence of observed dataset, we have to rely on the different datasets. However, if you go directly with the GLDS, anyone can ask why you have selected GLDS, why you have not used ESA, why you have not used MERA2 or IMDAA. So any of them can perform better for India, but we have to find out it. So these are some of the soil moisture datasets. So IMDAA is Indian Monsoon Data Assimilation and Analysis soil moisture dataset. So this website also provide lot of datasets like evaporation, soil moisture and various other datasets. So for India itself, you can also rely somewhat to this website also. And since we have to find out the impact of flash dot on terrestrial ecosystem, so we need to take some indicator which is indicator of terrestrial ecosystem. For terrestrial ecosystem we have taken GPP, that is a gross primary productivity GPP, and this data set has been derived from MODI's data set, that is moderate resolution imaging spectroradiometer. The thing is that this data set is available at 8-day temporal resolution. All the above data set is available either at 3 hourly or daily basis. So whatever the data set we have on 3 hourly basis, we can convert it to daily basis. So we can say all the above data sets we have availability on daily basis. The problem is that GPP data set is available at 8-day temporal resolutions. So whatever the spatial resolution we have regraded into 0.25 degree, 0.25 degree in the final version using IDW method, inverse distance weighing method. But the thing is that we are having same spatial resolution for all the data set, but not the temporal resolution. All are available at 1 day. This is available at 8 day. Okay.
Why IDW? Why not any other? We have other approaches. So is there any
No.
specific condition that we should use IDW, or is there any good rationale behind that we are using IDW? Secondly, at the temperature you said that you have used again the IDW. So at that point I want to ask what P and what K max or N max you have chosen. That is the maximum number of points possible. And then you are taking the inverse of the distances. So it may be the inverse of the square of distances, it may be cube distances, depends, right? So how you chosen that N max and the number of points inside the circle, number one, how you selected that P, and on which basis you selected these?
Okay. So first of all, there is no hard and fast rule that you have for regrading you have to use IDW. You can go for bilinear interpolation itself. Whatever the method you find reliable, you can go for that. There is no hard and fast rule that you have to go for IDW only. Since I used to do that, so I used IDW. Otherwise you can go for bilinear interpolation, or you can go for other methods to regrade the data set. Second, IDW is used because it is somewhat reliable, because if we want to find out the value for particular point like this point, so we have data set for all the corners of this room. So if you want to find out the value of this table from all the 4 points, it's better not to average all the 4 points, because that point and that point I is far away from this points. So they have less weightage on this data set as compared to these 2 points. So what we do, from this point we have this corner is very near to us, so we will give maximum percentage or maximum weightage, then we will give some less weightage to that, then we will give very least weightage to all these 4 corners. So that's why this method is more suitable, more reliable. However, there are several other methods which are performing better than IDW, so you can go ahead with that also. So there is no hard and fast rule for this type of regrading process.
Second is, again, stating that problem, that we take the inverse of the distances.
Yeah.
We take the general formula is 1 upon the distances raised to power p.
Right.
We need to select that p accordingly.
Right.
So in that case, in this case, what is the value of that p? How it has been selected?
Okay.
And secondly, we take the number of points, depends, right? Typically in rainfall data, they have selected a different radius for the different regions. So let's say in south we have more number of stations,
Okay.
density wise, but in the hilly areas we have less number of stations. So they have increased the stations accordingly.
Right.
The less number of stations in a bigger circle as far as hilly areas concerned. So my question is, here we are taking the graded data and we are taking it to the 0.25 cross 0.25. So in that case, how this can be changed, means taking the number of points for a specific point. Secondly, 1 upon d raised to power p, how that p has been selected.
Okay. So since for all across India we have used the same formula. So in that usually we used to take only 4 points, neighboring 4 points. but we can change accordingly the condition itself. We want to make the different homogeneous regions, that like hilly area we have to take more, for the plain regions we can have more sufficient number of points, that is 4. So we can do that, but in this study we have taken as homogeneous only, so we have not done separate for separate regions.
And maybe for this study, because since we are already having the graded data,
Yes.
we are already having the uniform points.
Yes.
But then again the question which remains is 1 upon d raised to power point. So what should be value of that we have in this item? Because it, as far as if I am correctly recalling, so that graded rainfall data, they are using the squared distance, inverse of the squared distance. So here what we have used 1 upon d, 1 upon d square, 1 upon d cube, and how that mean can be selected. And another which is my problem, actually.
Yeah.
What do you think that how many points should be sufficient enough, let's say for any climate variable over India, we are having those number of points. How many points will be sufficient to have the IDW of the entire Indian region?
Okay.
So it's just for the experience that you have done so many things. So I just want to have your opinion on that. So what do you think, what is the ideal thumb rule that let's say 300, 400, 500 or some points where you see that of course we need those scattered across the India. If let's say we are having 1000 points, but we are having 1000 points only in Tamil Nadu.
Okay.
That cannot be too representative of India. But if those 1000 points are scattered almost uniformly in the Indian region, then of course it will give a good representation of India. So let's say if I assume that these points are very well distributed, so then what your experience says that how many points are sufficient enough to have the IDW representation?
Majorly means, for example, if we find out this point itself, so minimum we need to have 3 to 4 points.
3 to 4 points.
Minimum near to this. But if you are saying that all the points are distributed across, for example, Tamil Nadu, and we are finding out for the central MP or that is of course will not help, even 10 points are there.
But for Indian cases,
Yeah.
we are having so many points. So how many points would you think that they are sufficient? If they are uniformly put in a good shape, they are distributed.
Then 3 to 4 points are more than sufficient to give this.
For all India, 3 to 4 points.
Means for any particular point we need to grade. For example, we have 4 grades like this corners, and for any of the corner like this one we have to find out, then we can have sufficient number of points required is 4.
So let's say if I'm making a graded data
Yeah.
from these scattered points, right? So how many points should I make? I mean, totality 500, 600. What do you think? I mean, like the graded data of rainfall has been made through the stations data.
Right.
So there are some number of stations, let's
Right.
say 1000, whatever. So you might come across such problems where you have dots all around,
Yeah.
which is not regularly distributed but well distributed. So how many points they give the good representation for the graded one?
Means for the good representation, more the number of points we have it obviously, but minimum we can have 4-5 points, then it can give good representation which can work for us. Otherwise, more number of points we will take, better will be the accuracy.
And in that case, how you selected 1 upon d raised to power that?
We have used from the literature that is usually used for precipitation, temperature, that we have used the squared one, which we taken from the literature. So whenever if you are going for different data set, I suggest you go for the literature. Whatever the literature suggests for that particular data set, you have to use that. Otherwise, you have to give the reason why you have selected cubic or other one. Otherwise, literature will suggest you better. Okay, so these are some of the data set. So the thing is that this data set is available at 8 day, above all the data sets are available at 1 day. So we need to match that resolution temporally as well as spatially. So spatially we have done using the regraded method. The temporal one, what we have to do, all the above data set are also converted to 8-day resolution. So that right now we have all the data set at 8-day temporal resolution and 0.25 into 0.25 degree of spatial resolution. Then this study is, yes, temporal resolution is same. Right now all the data set is at 8 day. From this slide itself, if we talk about one time step, that one time step is equal to 8 days, not a single day, because since if we are using these data set with this, it is not possible to use single day data with the 8 day. So we have to make the same resolution, either it is spatial or temporal. Spatial we have, and for temporal we have converted into 8 days, so that spatially and temporally they have same resolutions. So from this slide itself, whenever I say one time step or a daily basis, it means it is a 8 day basis. And in terms of flash dot, 8 day we used to say octard data sets. If we use 5 days, then it is known as pentard data sets. So here we are using 8 days, so I will call it as octard data set, OCTAD, octad. So these are the study area we have selected, means all the 24 river basins across India using India Virus 2014 classification. So this is the methodology. Initially we collected all the data sets which I have discussed in the last slide. That precipitation we have taken from IMD, Delhi potential evaporation, temperature, relative humidity and soil moisture, and based on that we have calculated the aridity index. And this is very generic formula for so long. From the literature you can see this is a ratio of precipitation to the potential evaporation. So this formula is very simple. From the literature itself we have used it. So once we calculated the AI, then we have to calculate the AI percentile value. You cannot use direct absolute value of AI. Absolute value of AI will not help you to find out the flash dot. Once you got the absolute value, please go for the aridity index percentile values using the I think in the last lecture itself we have calculated the percentile using KS test. We have find out the best marginal distribution, in which we have calculated the different distribution using KS test. Even though some of the study also use empirical CDF, but we can also fit the data into different distribution, and based on that we can calculate the AI, that is aridity index percentile. Once we have aridity index percentile, we will use this aridity index percentile for the flash dot computation. That I will show how we can calculate the flash dot. So once this flash dot detection or identification is done, we will initially go for the very first sub objective of this study, in which we will calculate the flash dot characteristics. The intensification rate, I think I have discussed in the definition itself, that flash dot have high intensification rate. So what is the intensification rate of flash dot across India? Flash dot characteristics like what is the mean duration of flash dot, what is the frequency of flash dot, what is the maximum duration of flash dot, what is the severity of the flash dot, these are characteristics. Intensification means the rate of intensification or the rate of decline of soil moisture at every time step, and the triggers, or we can say the drivers of flash dot. What are the major drivers which are causing the flash dot to occur in India? The second thing is, the second sub objective is related to the definition itself. Since we have developed a definition, so we need to validate the study that whether that definition is correct or not. So what we do, we will since we have calculated the flash dot using the aridity index, so what we do, in the same time we will take some hydrometeorological variables like precipitation, temperature, soil moisture, vapor pressure deficit, and we will find out that how these variables are behaving during different stages of flash dot. It means before the flash dot, what is the condition of these variables, during the flash dot, how these variables are behaving, and after the flash dot, how these variables are behaving. So that if we got to know that during the flash dot these variables are behaving similar to the condition which we have developed for the flash dot, if they are aligning with that it means we have developed the definition in the better way. Otherwise there may be some mistake in that. So the third one is the ecosystem response, that if we have a flash dot across ecosystem, then how our ecosystem is responding to these flash dots, and finally how our response of water use efficiency of our ecosystem to the flash dot. So in this we have not used only the water use efficiency, but we have used a new type of water use efficiency, that is known as underlying water use efficiency. So if we talk about this underlying water use efficiency, whenever you calculate water use efficiency on an annual scale or on a bigger scale, whatever the formula you know is working fine, but if you compute water use efficiency on a very finer scale like daily scale or sub daily scale, then you cannot go with this conventional method of water use efficiency. Then in that case you have to use one important parameter in the calculation, and that important parameter is vapor pressure deficit, VPD. And if you incorporate VPD in this formula, the old conventional formula for a smaller time scale, then that water use efficiency will be converted or will be known as underlying water use efficiency. So if you are going for an annual scale, you go ahead with this conventional method of water use efficiency, that is simply the ratio of gross primary productivity to the evapotranspiration ET. So that is GPP divided by ET. But if you are calculating for a daily scale or weekly scale, like at 8 days we have a resolution at 8 days. If you are calculating at 8 days, then you should incorporate this important parameter, that is vapor pressure deficit. And if you use this VPD with this, then so since initially if we have flash drought, if we want to find out the flash drought, we need AI, that is aridity index. So initially there are 4 conditions to satisfy whether there is a flash drought or not. The very first condition is that the first condition is that initially we need to check that if you are starting the flash drought identification, the current AI percentile and prior AI percentile should move from 50th percentile to below 50th percentile. For example, if you are starting to find out that this is flash drought condition or not, so initially this is the threshold, this is the 50th percentile, so the value should move from above 50th percentile to below 50th percentile. If this is the true, then we can say yes, we can start the flash drought identification from this point itself. This is the onset of the flash drought condition. So this is for the very first condition. If it is satisfied, we can go for the beginning of, or we can begin the flash drought identification. And then second, we will go for the second condition, that the mean decline rate of aridity index percentile should be greater than equal to 5%. And why we have taken 5%? We have taken from the literature. And why it is 5% or more? Because in the definition itself we say that flash drought is characterized by rapid intensification or rapid decline in soil moisture. So this 5% indicates the rapid decline in soil moisture at every time scale. So mean decline rate, it means every time step we are, if for example, if it is like for the very first it is 42 percentile, so the next one it should be minimum 5%, so it should be 37 percentile, then it should be 32 or less than 30 percentile. So every time step we have 5% decrease or more than this decrease. So this is the second condition. If this is true for one time, we can increase the time count like t equal to 1. If it is true for second time, we will increase the time count as t equal to 2, and we will go further once it is false. Once it is false, we will come for the third condition, that aridity index percentile should fall below 20th percentile. It means this value should fall below the 20th percentile. If it is going from this to this directly without going to below than 20th percentile, it means it is not a flash drought. This condition is also the mandatory condition. It should fall below 50th percentile, and finally it should fall below the 20th percentile. If this condition is true, we can increase the time count until unless this condition is true, and once it gets false, we have to go for the fourth and the final condition, that total duration, means here we are increasing the time count equal to t equal to 1, then t equal to 2, t equal to 3, and let's on. So if it is going like that, and if this total duration is equal to 3 or greater than 3, like 3 or 4 or anything, then we can say yes, that particular event is a flash drought event, otherwise it's not a flash drought event. Since our time step, one time step is equal to 8 days, so 3 time step minimum is requirement is 24 days. So if this condition is true for 24 days or 3 time step, then we can say yes, that particular event is a flash drought event. If it is false, we can say that that event may be a drought or not, we are not sure about that, but that event is not a flash drought event. So this is the condition of flash drought. In total we have 4 conditions. Initially we have to say that it must move from above 50th to below 50th, then it must have a rapid decline of 5% or more, then it should come below 20th percentile, because that is the second threshold which is very important to show the dry condition or arid condition, and finally it must agree or must true for 3 time step, and if it is true for that also, then we can say yes, that particular event is a flash drought. Otherwise it can be a normal drought like meteorological, hydrological, agriculture, we are not commenting on it, but we are very sure that it is not a flash drought. Okay, after that, once we have done this, then let's discuss some of the climatological characteristics across India, because if we are evaluating what is the arid condition across India, we must have some idea about the climatological characteristics across India. So in this we have plotted the spatial distribution of annual mean precipitation across India. Then the soil moisture we have plotted across India, that is the mean annual, not the daily basis data set. We have taken the mean of the annual data set across India for the precipitation, which is in mm per year. Then soil moisture here we have used in meter cube by meter cube, it means it doesn't have any unit. Then we have plotted the GPP, that is a gross primary productivity, to show the ecosystem indicator. Then we have used water use efficiency and underlying water use efficiency. So from the figure itself, I think you are working on Indian study area, so you all aware about the precipitation condition across India. You can see from the figure itself that annual mean precipitation over India is 300 to 650 mm per year, with a significant spatial heterogeneity, with a wide range of value which is ranging from less than 100 mm per year to more than 3000 mm per year. And this is the importance of India, that we are highly spatially and temporally heterogeneity we have. In some area we have precipitation which is very less, below 500 mm per year, and in some area we have precipitation more than 3000 mm per year. So this is the spatial and temporal heterogeneity we have across India in terms of precipitation and temperature. If we talk about the soil moisture condition or dry condition, we have very dry soil condition across central India and western India. If we talk about the GPP, we have the maximum GPP, maximum water use efficiency or maximum underlying water use efficiency across northeast India and western Ghat. And why it is so? Why we have maximum GPP, maximum water use efficiency across western Ghat or northeast India, and it is minimum across western India like Rajasthan? Is there any reason behind it? Vegetation or forest condition exists there. So water use efficiency is highest or higher for northeast India because that particular area is covered with the forest. However, in terms of western India, if we talk about, we have very low productivity in that particular area because we have high demand for evapotranspiration in western India like Rajasthan. So these are some of general results related to climatological variables across India. Then let's go for the flash dot. So here in this we are showing the results of frequency of flash dot, means the characteristics of flash dot across river basins of India. So in this we have divided the results or divided the frequency results into 4 seasons, because initially we have done for season like monsoon and non-monsoon, but the problem with this classification is that for monsoon we have 4 months and for non-monsoon we have 8 months. So comparing 4 months with 8 months is not the correct way to show the results, because obviously they are having 8 months, so it is completely double of that. So maybe frequency can come twice. So we can't say that in monsoon we have 4 events and in non-monsoon we have 8 events, because you are taking twice of the months. So you cannot compare with that. So that's why we have taken 4 different seasons as defined by the IMD itself. Even monsoon and non-monsoon is also defined by IMD, but here we have taken 4 seasons, that is winter season, pre-monsoon, monsoon and post-monsoon season. Winter season ranging from January to Feb, pre-monsoon from March to May, monsoon I think you all know that is June, July, August and September, and post-monsoon is from October, November and December. But when we are evaluating the result, we found that some of the events start in Feb like winter season and they are terminating or ending in pre-monsoon season. Some of they are starting in pre-monsoon and ending into the monsoon. So it is a very confusing stage that particular event is considered in which of the season. Either it is starting in winter and ending in pre-monsoon. So we need to consider in pre-monsoon or winter season. So it is problematic for us. So what we have done, we have also calculated the transition season. if a event is starting in one particular season and terminating into another season, so we have declared a transition season for that, and that event is considered into the transition season rather than any of the particular season defined by the IMD. So 4 events which are defined by IMD, then we have defined 4 different seasons. That is the transition from first season to second, that is winter to pre-monsoon, then transition from pre-monsoon to monsoon, monsoon to post-monsoon, or post-monsoon to winter seasons. So in total we have 4 by IMD, 4 by us, so in total we have 8 seasons. And in these results we found that during the monsoon season we found that majority of India is showing very low likelihood events of flash dot in the monsoon season, but the highest frequency of flash dot is observed in post-monsoon season, which is followed by the transition period of different periods. So why you feel that in the post-monsoon season or after the monsoon we have highest flash dot frequency? Because after the monsoon or like in the post-monsoon or non-monsoon season, we have long dry spells with negative precipitation anomalies, and this negative precipitation anomalies rapidly reduces the soil moisture, and this rapid reduction in soil moisture finally triggers the flash dots to occur. So this is the reason that we have less flash dot in monsoon and high after the monsoon itself. Yes. Can you speak louder, please? Yes, for example, if we are talking about transition from winter to pre, we are considering January, February, March, April, May. Maybe it start in Feb and terminating into May. It may start in January and it may terminate into March. So all the 5 months of 2 season or all the 5 or 6 months of 2 season, it means this is a transition from winter to pre-monsoon irrespective of month. It can start from mid-Jan, it can end into the mid-March, mid-April or mid-May. We are not concerned with this. If it is going to start in one particular season and terminating into another season, we are creating the transition season for it. Why we are not creating the transition season from winter to directly to monsoon, like transition from winter to pre-monsoon, pre-monsoon to monsoon? Is there any question for you? Means we are creating a transition season from winter to pre-monsoon. We are not creating the transition season from winter to pre-monsoon and then it will come in, it will start in winter, it will end in monsoon. It will start in pre-monsoon and it will end into post-monsoon. Why it is so? Because flash dot don't have high durations like seasonal duration or year longer duration. For in that case we have conventional dot. Flash dot don't have high duration like seasonal duration or year longer durations. Then the second thing is that we have shown the flash dot intensification rate. Yes. I am unable to get. Dry spell. Okay, dry spell means the spell means this is here we are not defining the dry spell. Dry spell indicates that when we are not getting precipitation for a longer period, in that case itself it is showing the results, because it is showing these results in the after the monsoon or before the monsoon itself, not during the monsoon. So in the monsoon itself we have the precipitation, but in the non-monsoon season we have long dry spells, like for long months or 2 we don't have the precipitation, due to which it rapidly cause rapid decline in the soil moisture condition, because just after the monsoon, initially in the monsoon season we have high saturated condition of soil moisture. Once after that we have further very fast decline in the soil moisture condition just after the monsoon itself. So we don't have the precipitation, then soil moisture declines from particular value to lower value. So that creates a soil moisture reduction in a very fast or intensification manner, due to which it causes the flash dot to occur. So here we are defining the flash dot intensification rate, means at what rate soil moisture is declining at every step. So we found that the high intensification rate of flash dot are more common in humid regions like northeast India rather than semi-arid regions like western India. So this is same results which we have observed in the news clip for the England, that England studies clearly told us that even the damp condition or humid conditions are also hit by the flash dot. Here itself we found that humid area of India itself is experiencing the high intensification rate of flash dot rather than the humid arid or semi-arid regions of India like western India. And this suggests that anthropogenic climate change has altered the traditional climatic regions across India, and whenever if we are talking for normal conventional drought, we have different policies to address the normal drought risk. But if we are talking about the flash drought risk, we have to give more attentions to address the flash drought risk in humid regions or semi-humid regions rather than arid or semi-arid regions, because we have perception for the drought that if we have arid or semi-arid regions, they are more vulnerable to drought conditions. We are more vulnerable to drought conditions rather than humid or semi-humid regions. But in case of flash drought, it is not like that. It is completely different. It suggests that humid or semi-humid regions are more vulnerable because they have high intensification rate of flash drought across India rather than arid or semi-arid regions. Then the third important thing, we need to find out the triggers or the drivers which are causing flash drought to occur in India. So from the literature I got to know that some of the definition are using precipitation as an input variable to find out the flash drought. Some of them are using temperature, and some of them are using soil moisture to define the flash drought. So we can say that all the three variables, either in terms of precipitation, temperature, soil moisture, all three are playing crucial role to define the flash drought. So we have taken all the three parameters like precipitation, temperature and soil moisture. However, it is also possible that precipitation along with soil moisture is causing flash drought. It may be possible that precipitation along with the temperature can cause the flash drought to occur in India. Or the third combination or the final combination is possible that all three are togetherly causing the flash drought to occur in India. So we have made 6 combination in total, like precipitation alone, temperature, soil moisture, then the combination like precipitation temperature, precipitation soil moisture, precipitation soil moisture temperature, and the combination of all three like precipitation plus temperature plus soil moisture. And the results declare that majority area, precipitation along with the temperature are major triggers or drivers of the flash drought across majority of the study area. However, in some area we have individual effect of soil moisture and precipitation acting as a trigger across some regions, like northeast India we have precipitation, and for northeast it is soil moisture. Then the third thing which we need to do is the soil moisture data set, because we need to use soil moisture to find out whether how our hydroclimatological variables are behaving during different stages of flash drought. For that we need soil moisture data set. But since we don't have observed or in situ soil moisture data set, so we have used this triple collocation approach to find out the best soil moisture data set for our study area. Initially I told that we have taken the soil moisture from 5 different sources. Out of that we have to find out the best one for us. So what we do, we will apply the triple collocation approach. So maybe I think you have heard about this triple collocation approach. This is a very good approach. It will not, for example, if we have 5 or 7 or any number of data sets we have, it will not treat any of the data set as observed truth. For example, sometimes we do the bias correction. We use IMD precipitation data set as the observed data set, and we think that this is the correct data set for us. But in case of triple collocation, it is not like the case. We are not treating any of the data set as perfectly observed truth. Every single data set have its own value, and we are treating every data set at the same things. We are not treating any of the data set as perfectly observed truth. So why its name is triple collocation? Because at the same time we are analyzing 3 data sets at the same time. You can see from all the figures, for the very first figures we have taken 3 data sets, that is 1, 2, 3. Then we have taken 1, 2, 4. Then we have taken 1, 2, 5. Then we have taken 1, 3, 4. At the same time we are taking 3 data sets. For every same time we are calculating the R square value and correlation coefficient value. How? For example, we have taken the first, second and third data set at the same time. then we will use of these three values, we are defining a unknown truth using these three values. Means we have three data set of soil moisture 1, 2, 3. Out of combining all these three, we will create an unknown truth, and based on that unknown truth we will find out how the first data set is varying significantly varying from that unknown truth. Then we will check the relationship of second data set with unknown truth, then we will check the third data set with this unknown truth, and we will find out the RMSE value or correlation coefficient value, R square value we will find out here. Based on that we found that in all the results we found that GLDS data set and ERA data set is performing better as compared to the other three data sources. So we can say yes, we can use this. However, we have to use one. So we compare GLDS and ERA data set, and we found that on a very finer resolution GLDS is performing better as compared to ERA data set, and the reason is ERA data set has some missing value due to which it is not performing better than GLDS. So in this study we have used GLDS 2 version NOAA soil moisture was further used in this analysis for the drought classification. So this is my second sub-objective of this study, that here we are showing that how hydrometeorological variables are behaving during different stages of flash drought. Why this objective is required? Because if we have flash drought and defined by the aridity index, we have to calibrate that value. We have to calibrate that definition, or we have to validate that definition whether it is correct or not. So we know that we have to define the variables. So here we have taken four variables. The first one is the soil moisture, second we have taken precipitation, third we have taken soil moisture, temperature, and fourth one is vapor pressure deficit. And we have defined four stages of flash drought. The first one is onset, before onset, means before the flash drought occur or starts. The second one and third one is the onset and recovery condition, or we can say during the flash drought, before the flash drought, and this is the after the flash drought. We have to find how the different hydrometeorological variables are behaving during different stages. So if we talk about soil moisture, before flash drought occurs, the soil moisture percentile is in very good stage, that is across around 50th percentile. But once it enters into the flash drought, once the onset of the flash drought starts, once the value started or enters from above 50th to less 50th percentile, from 50 percentile it reaches to 41 percentile, just start of the flash drought. After that, once it enters into this recovery stage itself, this 41 percentile reaches to 90th percentile. It means from very good soil moisture conditions we have a quick transition to much drier condition, and once after the recovery or once after the termination of flash drought, this is recovered from 90th percentile to 36th percentile. It means we can say soil moisture recovers very quickly after the termination of flash drought. If we discuss about the precipitation itself, I think from the figure itself you can see that during the flash drought the precipitation is in negative form, but before and after the precipitation is recovering very fastly. So we can say that flash drought are indicated or characterized by well below normal precipitation during the flash drought, but before and after it is not below the normal precipitation. Similarly goes with the temperature and vapor pressure condition, that during the flash drought this is having high temperature condition, but before and after the flash drought the temperature condition is not very high as compared to during the flash drought. So it means during the flash drought soil moisture is declining very fastly. It is showing very drier condition. If we talk about the precipitation, it is very less. If we talk about temperature, it is very high. If we talk about vapor pressure deficit, it is very high. It means all the variables are validating the definition of aridity index to define the flash drought. That during the flash drought we have less percentile of soil moisture condition, we have less precipitation, we have high temperature, we have high vapor pressure deficit, and also we are expecting the same for the definition if we are developing like this. Then the fourth part or third part of this presentation is that how our ecosystem is responding to flash drought. If flash drought is occurring, how we can define that flash drought is our ecosystem is responding to flash drought event or not. So we have two indicators to define whether ecosystem is responding to flash drought or not. The very first parameter to show that ecosystem is responding or not. So first one is response frequency and second one is the response time index. So in a very layman terms, we can say after how response frequency means how frequently our ecosystem is responding to flash dot event, and after how much time our ecosystem is responding. For example, if we have a flash dot, if we have 4 flash dot, our ecosystem is responding to all 4, or our ecosystem is responding to 3 or 2 or 1 event, or it is not responding none of them. Second thing, if it is responding quickly, or it is responding after taking some time to respond. So these are 2 variables or indicators we will calculate for that. So here we have shown the response of gross primary productivity to the flash dot events. So we have shown the response frequency and response time. So we have no substantial difference in terms of response frequency, but we have seen some longer response time in northeast India, or this part, Indo-Gangetic plain. So I ask you whether this longer response time is good for us or bad for us. Ecosystem should take more time to respond to the flash dot, or it should take less time to respond? More time. Why? Because if it will take very less time, it means it get easily affected by flash dot. If it is taking longer time, it means it have high resistance, so it will not get affected very easily in a very short period of time. But if it exists for more periods, we don't have any idea about that. So to get the better clear picture, here we know that longer response time is showing. It means this Indo-Gangetic plain have lower risk to the ecosystem. They have lower risk to the flash dot because they are taking longer response time to respond the flash dot events. So let's understand at what period of time our ecosystem starts affecting. So for that we have calculated the water use efficiency or underlying water use efficiency and their response to flash dot. So here you can see 2 important findings. Initially we have shown water use efficiency in this and underlying water use efficiency in this, and I declared the use of underlying water use efficiency in the methodology section, that if we are taking vapor pressure deficit, then that water use efficiency is known as underlying water use efficiency. So you can see that water use efficiency value are always lower as compared to this, and this is due to vapor pressure deficit. The important finding in this study is, or in this result is, that you can see that this part is showing the initial phase of the flash dot, and this is showing the recovery stage of the flash dot. If we talk about the initial phase, the value of water use efficiency or underlying water use efficiency are higher. However, these are going to be declined here. Means initially value are higher, but these are decreasing at the end or during the recovery stage of flash dot. What this high value indicates? The high value of underlying water use efficiency or water use efficiency indicates that our ecosystem is highly resistive or highly adaptive to the flash dot risk. But this resistance or this adaptation is going to be decreased with increase in the flash dot duration. Initially it is showing high resistance, but this resistance is decreasing due to increase in the flash dot duration. So this is the finding of these results. So finally we can conclude that based on this study we can say that aridity index can be a useful indicator to define the flash dot across India, because it is highly validated by the climatological variables also across different stages of flash dot. Second, if we talk about the intensification rate of flash dot, they have high intensification rate in humid regions rather than semi-arid regions. So we need to give more attention. We need to develop more better policies for the flash dot in terms of humid regions or semi-humid regions rather than arid regions. Whatever the policies we have for the traditional drought, we can't use for the flash dot also. We have to change it because they have high intensification rate in humid regions rather than arid regions or semi-arid regions. If we talk about the triggers or the drivers of the flash dot across India, we can say majorly the precipitation, means lack of precipitation and high of temperature are the major triggers which can cause the flash dot across India. However, some parts have individual effect of soil moisture and precipitation itself. Next thing is that if we talk about the ecosystem response, our ecosystem is highly responsive, means more than 97% of flash dot are responded by the ecosystem. For every single event, our ecosystem is sensitive it is responding to every single event. It means we can't say that flash dot is not affecting our ecosystem. For every single event, our ecosystem is affected. How we get to know that our ecosystem is affected? Because we are taking GPP value. If during the flash dot that GPP value is going to be decline, it means our ecosystem is responding to the flash dot. Due to flash dot condition, that GPP value is going to be decreased. So that is the response of that. And if we talk about this vegetation adaptation, initially we see that water use efficiency value are very high in the initial stage of flash dot, but these value going to be decreased in the later stage of the recovery of the flash dot. It means initially our ecosystem is highly resistive. It is showing better vegetation adaptation to the drought condition, but this is going to be decreased. It means our ecosystem resistance power is going to be decreased with increase in the flash dot condition. In this condition, we have used top 1 meter soil moisture data set as a root zone soil moisture, but since we got to know from the reviewer that sometimes we have plants which have roots deeper than 1 meter. So this study is also applicable to that particular crops or not, because here we are taking only 1 meter. Some plants have roots deeper than 1 meter, for example up to 1.5 or like that. So can we use for that also? So we have done all the methodology part again for the 2 meter, and we found that results are very similar. So no need to take 2 meter soil moisture data set again. So it's reasonable to use 1 meter soil moisture data to analyze the impact of flash drought. And these results are very helpful whenever we develop the effective or mitigation plan for the flash drought risk reduction strategies for India. And this paper was published in Journal of Hydrology, and also the second part of this study has been published in Journal of Hydrometeorology in 2024 itself. Thank you. So any questions? Yes, please. Yes, during the monsoon it is very less. After post monsoon it is very high. For example, if we have monsoon across any particular area, and we have break in the precipitation for so long, like for a month or 30 days or more than 35 days, then obviously, because initially when the rain come in the starting of the monsoon, the soil moisture condition got improved, and after 35 days continuously we are not getting the precipitation, so obviously the soil moisture condition starts declining in that 35 days, and that if there is a rapid decline, so obviously it can cause the flash drought in that monsoon period also. Yes, but minimum it requires 24 days to occur. For example, if you are having the precipitation every 5 days, then I think soil moisture will not show high decline in the soil moisture conditions. So it minimum needs 24 or 30 days or more than that, so that it have high decline in the soil moisture condition for continuously 24 days itself. Otherwise, if you have precipitation after 15 days itself, so obviously the soil moisture will not decline up to 20th percentile. It may just regain its soil moisture condition, and it from, for example, from 38 or 30 or 25, it will regain to 30 percentile. So it will not go below the 20th percentile. So it will not cause the flash drought. But if it will go for more than 30 days like that, and it can go below the 20th percentile, so obviously it can cause flash drought in the monsoon period itself. Any other question, please? So if you don't have a question, we have a question in form of quiz. And if you score 70% in that, then only I will distribute the certificates. So within 20 minutes I'll evaluate all. If you have 70% marks in the quiz, then only I will distribute the certificates to that participants. Just signing the register in the register for the attendance doesn't make sense that you will get the certificate. If you are scoring minimum 70%, then you will get the certificate for Gyan course. So I'll just share the feedback form with you, and then I'll share along with feedback itself, I'll share the quiz. Okay, thank you. If someone is sitting, I think आप दो लोग एक साथ मत बैठिए, please sit alone, otherwise there is no sense of that. Please sit alone. ऐसा people please separate. जो भी ऐसा हैं वो सारे साथ में बैठे हैं. तुम लोगों भी एक टेस्ट. आलोक, नो यूज ऑफ मोबाइल. कोई भी मोबाइल यूज नहीं करेगा. अगर किसी को फीडबैक फॉर्म या फिर किसी को क्वेश्चन पेपर नहीं मिला हो तो बता दीजिए. Not a managed student or ISET student, then only you will get to know whether you are studying.
तो चालू है ना?
जरूरत नहीं है, लेकिन जब व्यवस्था है तो
सेटिंग, ठीक है, मोमेंटम प्रीमेटर सर्कल एसएस मोमेंटो एंड सेटिंग,
ये नहीं हो रहा है,
ठीक है, कोई बात नहीं। और फिर लिखिए मैं प्रेजेंट मोमेंटम बस
उसको साइड से बता देना।
बस ठीक है, स्टार्ट वो लगा लो।
ऐसा लगाता है क्या?
Good afternoon everyone and welcome to the valedictory session for this Gyan course on climate change and compound hydrometeorological events, insights from data and modeling. I would like to welcome Professor Dr. Priyamitra Manoj sir, Professor Liksing Wang sir, Professor Vishnu Prasad sir, Dr. Sumis Swankar sir and Dr. Vikas Punia sir for this valedictory session. I would request Dr. Priyamitra Manoj sir to kindly say a few words. I would now request Dr. Sumis Swankar sir, Assistant Professor from ICER Bhopal to kindly say a few words.
So I really thankful to Center for Water Excellence, Manit Bhopal, providing all the infrastructural facilities. Really grateful to Head of Center, Professor Vishnu Prasad sir, for giving such, we have conducted all these exercise. Also for the Gyan course, Gyan coordinator, local coordinator as well. Also Professor Liksing Wang, who accepted our invitation, and because of so many, hiccups, we could finally manage to organize this workshop. And also to you as well, because you have actively participated in this particular workshop, and whatever we have given a lecture on different types of hydroclimatic extremes as well as how do we model them. So you got some preliminary ideas about, and then you can pursue it further. And we tried our best to give you introduce you lots of tools and lots of the data sets as well as the modeling tools as well, so that you can relate with your research work, and you can do you can apply these tools and hydroclimatic extremes analysis in your research work as well. So I really thankful to thank you to your participation. You have really asked a very interesting questions which are eye opening, and we have tried our best to answer all of your queries as well. So if you have any further question, queries or comments or suggestions, you can still connect with all of us, and you can let us know about your thoughts. Thank you so much.
Thank you, sir. I would now request our foreign faculty, Professor Liksing Wang sir, to kindly say a few words.
All right, good afternoon, everyone. I guess first, congratulations for finishing this workshop. I really hope you learned something useful, and get some new ideas. Maybe get to know some new colleagues that's very important for this type of gathering, right? So you learn from each other, you learn from ours, but you also learn from each other. I really hope this is a great experience for you all. Really congratulations for finishing this. I know it's hard, 5 days, and a lot of new ideas, a lot of new things, but I hope that's useful for you in the long term. So for me, I'm really grateful for this opportunity to be here. So it's the first time I visit Bhopal, the second time I visited India. So it's really a great experience. Everybody is so friendly. I enjoy the hospitality, right? So I really thank the host faculty, Dr. Vikas, for the invitation and for everything done for me, for the visa assistance and he has been very busy writing email every day to the external affairs, including Dr. Somil, try to get my visa approved. So which, is a little bit harder than I expected, compared to my first experience. So, but I'm glad I'm here. I really enjoy the experience. I hope you do as well. I really appreciate department head from the center for your whole, give us the logistic assistance, and for Dr. Premier Major for the hospitality, for the friendship. So again, thank you guys for being here. I really hope you enjoy this experience as much as I do. Thank you.
Thank you, sir. I would now request Head of Center of Excellence in Water Management to kindly say a few words. Professor Vikas, Professor Vishnu Prasad, sir.
Good afternoon to all. Let me first congratulate the coordinators, Dr. Bitras and Dr. Somil, for organizing successfully this 5 days course, which is completing today. And our center are especially thankful to Dr. Lekfin, who has traveled from USA to Bhopal, facing many hurdles during the process, and finally this has been taken place. I hope that in 5 days course you might have learned about climate change, basis of climate change, very different models, what is hydrometeorological parameters, how to develop the relations, models using those data, and hope that it will be useful for your future work and research at a institute or organization. Secondly, I hope that your stay may be comfortable here, because it is summer season, little bit hot is there, but I hope that Bhopal is a good city and climate is also at present it is comfortable. That's all. I wish you all the best for your future also. Thank you.
Thank you, sir. Lastly, I would request Dr. Vikas Punia, sir, to kindly say a few words.
So, thank you to all. So initially, I'll thanks to all the participants who have came from different institutes to reach to the Manet Bhopal, and very thankful to you because I have postponed this course twice. Initially, it is on 31st March. That is my silly mistake that I didn't know that 31st March is a national holiday. So I shifted to 1st April to 5th April. Then further, there is a delay in the visa. So it postponed to 21st April to 25th April. In that period also I struggle a lot with Ministry of External Affairs, and we are getting every day we are sending emails, but we are not getting any fruitful result. And finally on 17th or 16th April I think we got a visa. So in very short period of time it is very impossible to travel for Lexin Wang also. So we have postponed again. But anyhow we have 54 participants registered in the initially for the very first date. After 2 postponed events, we have 4 participants requested to refund request for their registration fees. So we have done the registration refund to them. After that, out of 4, 2 have requested them again that please register us again. So finally we have 52 registration at all in this date, that is from 19 to 23rd May. In this total duration of event or organizing these events, Professor Lixin Wang is a great help to us. Every single day I am emailing him or I am inquiring about his visa. Every single day he is saying no issues because I will take care, no issues, I will take care. Then I tell him that it is not possible to travel, so he told me no issues, you can postpone it, I will take care of it. Even initially he wants to come with his family, like his son and wife. He paid his visa fees also, but due to this postponed events, he is not able to carry with them because right now they are busy with some other works, like his son has to go school. So we have postponed, so he has postponed their tickets and he is coming alone. So that is also not good for us because he wants to explore India with his family. But right now he don't have a choice to roam around alone. So he have to visit Jaipur alone only. And I am thankful to our head of the center, Professor Vishnu Prasad sir, for giving every single support to this Gyan course to organize every single thing. I also thankful to my PhD students, master students. They have helped me a lot in all 5 days before that and after that also. So thank you all. Thank you.
Thank you, sir. I would now request our HOC sir to kindly present the memento and shawl to Professor Lixin Wang. I would request Dr. Vikas Punia sir to kindly present the photo and certificate to Professor Lixin.
So this is a certificate from our side.
I would request Dr. Somal Swankar sir to kindly deliver the memento and certificate to Dr. Priyamitra Manoj sir for delivering the lecture and hands-on training on as well. I would further request Professor Lixin Wang sir to kindly present a memento to Dr. Vikas Punia sir. He is the host, he is a course coordinator for this Gyan course from Manit Bhopal. I would request Dr. Priyamitra Manoj sir to kindly deliver the memento to Dr. Somal Swankar sir. He is the course coordinator from ICER Bhopal. Now we'll move on to the distribution of certificates. I'll request Professor Lixin Wang sir to kindly distribute the initial few certificates. So,
We'll call the name.
we'll call the name of the participants will come. I'll just
You just come here. आप थोड़ा सा ऊपर नीचे।
Ayush Verma, Deepak Kumar Singh, Harshvardhan Solanki. कितना हुआ? अच्छा। now request Dr. Priyamitra to deliver the next few certificates. Ankita Singh. Ankit Kumar. Kundan Kumar Sahu. Pragya. I would request Dr. Somas Swankar to kindly deliver the next few certificates. Simran. Priyanshu. Nakhawat. Abhimanyu Verma. Sir. I know. Shalini Singh. Anjana PS. I would now request Dr. Vikas Punia sir to kindly hand over the next few certificates. Pankaj Narula. Swarit Gupta. Preeta Manurag. प्रीतम चौथे नहीं है सुप्रया सोनालिका राज. Pandurang Chaudhary. Amal Raj. Shomo Kundu. बाकी को रिपीट करें क्या? श्वेता कुशवाहा. हिमांशु झाड़िया. Ankita Mukherjee, that's right. So we have come to the end of the validatory program. अच्छा. भानु नहीं है ये. वहाँ पे. वहाँ पे. participants who want to say a few words or give feedbacks, then they are most welcomed. Any feedbacks, anyone? So, it's for YouTube actually.
Respected HOD of this department, Shah sir, then our guest faculty for this program, Dr. Lixin Wang sir, then course coordinator of this program, Dr. Vikas Punia sir and Somil Sorankar sir, then Priyanshu Munot sir, and all my dear participants. I am one of the participants that Vikas sir has already told the story about this course, and he has taken that to registration back. That is one of the I am the participant of that. Finally, that Wang sir's that aeroplane has landed in India, and I thought that we are going to register for this course. Actually, I am very much thankful to be a part of this course that is on compound hydrometeorological events, insights from data and modeling. So since last 5 days, we have learned different these concepts, and these all different concepts they have putting into well structured and insightful programs. So as a part of this participant, that I have learned many things, and these things or whatever the concept which I have learned, that definitely I will going to be implement in my classes through that syllabus framing. So I'm going to frame that new syllabus, or maybe whatever the concept which I have learned, that will be incorporated in my syllabus also. So definitely sir, this was a wonderful course. I have learned a lot from this course, and definitely I would be happy to again to be a part of that in future coming course. Thank you very much.
Thank you, sir, and thank you everyone for joining with us on this course. And anyone else wants to share anything? Anyone? Okay. So thank you everyone once again. Thank you.
प्रोग्राम में होगी ना।
Hello. So this is the concluding remarks for the Gyan team. For this 5-day course we have completed anyhow. So thank you the Gyan team, the Ministry of Education, Government of India and IIT Hyderabad for every support. Thank you so much.